Hey guys, welcome to IB Psychology. In this video, we'll be looking at the topic of biological approach and more specifically neuroplasticity. So, by the end of this video, you'll understand what neuroplasticity is, how it helps to form neural networks, what it means when we say neurons that fire together, wire together, and how it's supported by studies like Dragansky's study. So, did you know that when we learn something new, such as learning how to play the guitar or learning how to ride a bike, our brain literally changes, and this is due to a process called neuroplasticity, which refers to the brain's ability to change its structure and function in response to experience. And in simpler terms, it basically means refers to how our brain is constantly rewiring itself based on what you do, think, and learn. So we can say neuroplasticity is the brain's ability to change and adapt. Okay, so when neuroplasticity occurs, our brain forms neural networks, and these are basically systems of connecting neurons that work together to perform a specific task, like reading, walking, or speaking. And when we learn something new, our brain forms new connections between the neurons, and the more we repeat the task or piece of information, these connections become stronger. And the main idea is basically neurons that fire together, wire together. This is very important. You have to remember it. And this phrase is basically said by the neuropsychologist Donald Hebb, and it means that when two neurons are repeatedly activated at the same time, they strengthen their connection. This can be visualized through this diagram here, where before we started training, neural networks are not connected and there's not a lot of them. However, after two weeks of stimulation, we can see these neural networks starting to form and more of them starting to occur. And after 2 months of stimulation, we can see how all these connections are formed now, and they're all very complicated and formed together and connected together. So you might ask, well, why do we form neural networks? What's the point of it? Well, basically it's because when we form neural networks, it makes our thinking, remembering, and acting more efficient. So imagine playing a piano. At first, it might feel like difficult or clumsy. You might feel clumsy. But with repetition, the same neurons are activated again and again. And over time, these neurons strengthen their connection, and it forms a reliable network that makes playing automatic. So, key points are, when we form neural networks, it improves the speed and accuracy of mental processes. Mental processes. It stores information as memory. It allows for automatic or habitual behavior. And it increases efficiency by reducing cognitive load. Okay, now let's look at some possible SAQ questions on this topic. So, one possible question is, explain neuroplasticity making use of one study, or outline how neural networks are formed with reference to one study, or explain the formation of neural networks with reference to one study. And they all mean the same thing. When you talk about neuroplasticity, you have to talk about how neural networks are formed And when you talk about neural networks, you have to talk about neuroplasticity. Therefore, we can write one SAQ to answer all three questions. So I'll be walking through how we structure this SAQ out and how we write an SAQ that will earn you 9 marks. So in paragraph 1 of every SAQ question, you have to talk about basically explain what the question is trying to ask you. So in this case, it's trying to ask you what neuroplasticity is or what neural networks are. So we first have to, in paragraph 1, explain the definition of it. And yeah, so we start with talking about how brain is, giving like a little introduction. Brain is dynamic and interacts with the environment. It is sculpted by experience, and neuroplasticity is the ability of the brain to constantly change in response to learning, experience, and injury, making and breaking the connections. This is the definition of neuroplasticity. And then we talk about what neural networks are, because as we said before, neural networks form when neuroplasticity occurs. So we talk about neural networks are basically series of connected neurons where information travels along. And we can talk about how neuroplasticity is observed by measuring changes in the gray and white matter in the brain, typically through neuroimaging techniques like MRI. And this is explained in the videos above or before. We talked about the imaging technique called brain imaging technique called MRI. You can go check it out. Then we talk about the structure of the brain and what happens to the brain when neuroplasticity occurs. So gray matter is basically a part of the brain, the outer part of the brain, and it's mostly made of somas and dendrites and unmyelinated axons, where information is processed and passed in close proximity. And white matter is involved in transmitting signals between brain regions. Neuroplasticity involves the formation of new synapses as neurons form neural networks or cell assemblies when learning due to stimulation, strengthening connections with repeated activity, which enables us to perform tasks faster and more efficiently when expressing a behavior. And over time, these unused synapses are eliminated through a process called synaptic pruning, refining the brain's efficiency in processing information. Synaptic pruning will be explained later on in the video. I'll be going over what it means, and yeah. But basically in paragraph 1, we just explain the definitions of the terms and what occurs during neuroplasticity. In paragraph 2, we always have to talk about a study that supports our idea. And in this video, I'm going to talk about Dragansky. And there's already a video made that goes in depth of what happens in Dragansky study and what you include. But basically, you talk about the A, M, P, F, C. And C is here, always. So A is basically the aim. M is the method. P is the procedure. And F is the findings. So if you want to understand what happened to Dragansky, you can go check out the video. But Dragansky is basically a study that uses an MRI to scan participants, jugglers, and basically investigate how their brain changes after learning a specific task, which is juggling here. And this supports the idea of neuroplasticity. So in our final paragraph, paragraph 3, we talk about the conclusion of the study, and we have to link the study to neuroplasticity and how the conclusion or the finding supports the idea of neuroplasticity. So here I first mentioned the conclusion. So I said, in conclusion, Dragansky's study supports the concept of neuroplasticity by showing that the brain can adapt and change structurally in response to new experiences, such as learning to juggle. So here, I not only talked about how it supports it, but I also linked to the study. I talked about how it supports by showing how the brain changes when learning how to juggle. So you have to link to the study. You have to specifically mention the study to show that you understand the study and at the same time understand how it supports neuroplasticity. And I talked about the use of MRI allowed researchers to observe the formation of new neural connections in the gray matter of the midtemporal region, illustrating how the brain can reorganize itself by developing new synapses. So here I talked about what the study did. I said that they used MRI scans, again linking to the study, and I talked about how specifically it shows how the brain can reorganize itself as it develops new synapses, and there were more gray matter in the midtemporal region, which supports the idea of neuroplasticity. And this, I gave a little last concluding sentence. This demonstrates neuroplasticity in action, where practice and experiences shape the brain structure over time. And yeah, that's the end of this SAQ that answers 3 of these questions here. Now I'll be moving on to another possible SAQ question on neuroplasticity. And the question is, explain synaptic pruning or neural pruning with reference to one study. So synaptic pruning is basically when your brain is busy, while your brain is busy creating new connections, it also eliminates weak or unused ones. And that's basically synaptic pruning. And this helps us to be more efficient as well. So when we don't practice a task, let's say I haven't practiced piano for 2 years, I get bad at it. I can't play as good as I was before because I stopped playing and I stopped activating my neurons, and my neural networks have been broken and they're not used anymore. And this is the process called synaptic pruning, and we become less efficient at playing that task. Therefore, it's very important to constantly repeat and practice a skill if we want to be good at it for a long time. So, how we structure this SAQ, like what we said before, is we first, obviously, in paragraph 1, talk about what synaptic pruning is and what it does and what occurs in synaptic pruning. So I first talked about synaptic pruning is a process by which the brain eliminates unused synaptic connections, making existing neural networks more efficient. So we eliminate the ones that we don't use so we can focus on the ones we use to be more efficient at the task we want to perform. And then we link to neuroplasticity again, and we say it plays a crucial role in neuroplasticity, where the brain's ability to reorganize and adapt in response to environment demands, whatever, basically defining neuroplasticity again. And by removing weaker synapses, the brain strengthens the more frequently used connections, allowing for more efficient information processing. And yeah, that's a paragraph 1 done. It's shorter than the one here because we talk less about stuff that we don't need, because they mostly want to ask you about synaptic pruning and neural pruning. And then the study we use again is Dragansky's study. So I'm not going to talk more about this because I already have, and there's a specific video made on it. So in paragraph 3, we obviously talk about the conclusion of the study. So I said Dragansky concluded that the brain will perform structural changes in response to environmental demands such as learning, and reduces when that stimulation is taken away, in specific referring to gray matter. So in the study, it showed how the gray matter volume decreased when the participants stopped juggling, and this shows that the brain can prune synaptic connections when the neural network is left unused, and thus making the functioning of neural networks more efficient. And yeah, this study basically supports the idea of synaptic pruning. And there we go, 2 SAQ done, and it's not hard if you think of it. It's the same study used, and you just have to tweak it a little bit to fit in with what the question's asking you. So if the question is asking about synaptic pruning, obviously talk about that in your first paragraph, and then the study is the same. You write the same thing, and then the conclusion, the most important thing about the conclusion is, obviously paragraph 3 is the hardest part to write. It's like it requires a bit more of critical thinking, and yeah, the most important thing is you link it to the study. Link it to what the study did and how that supports your idea. And that will get you a very high mark, and you'll do really well. Yeah. Thank you for watching this video. I hope you guys enjoyed it and found it helpful.